countries like Nepal or other, which are struggling to find the resources for this high performance computing. So in the first sessions, we will listen their activities and collaborations related things. And in the another sessions, that will be the more discussion type of sessions. So that will be led by Professor Francis. And for the first session, I am here for the moderations. We have 6 speakers. The first speakers is Dr. Piawut Srisaikul. He is from Thailand, NSTDA Supercomputer Centers. Dr. Piawut holds a BSc degree in physics from Chulalongkorn University, Thailand, and a PhD from Auburn University, USA. Since 1995, he has been a researcher at a NECTEC, a member of National Science and Technology Development Agency, Thailand. His experiences includes computational science, high performance computing, geoinformatics, data analytics, research program management, and organizational management. Currently, he is the Deputy Executive Director of NECTEC and in charge of research and development, AI and advanced electronic sensing. In addition, he is a director of NSTDA Supercomputer Centers, that is also called the Thai Supercomputers, one of the NSTDA's national S&T infrastructure units. So I'd like to welcome Dr. Piawut for his presentation.
Thank you very much for the introductions. May I share my screen? Okay. All right. Well, can you all see it well?
Yeah, Dr. Piawut, it's great.
Good. Well, first, I would like to thank APAN for the opportunity for me to give a short presentation in this event, and also since I might not be able to stay for the whole sessions, the organizer has kind enough to rearrange the slot for me to be in the starting of the sessions. Well, my name is Piawut Srisaikul. I work with National Science and Technology Development Agencies, and part of my job is leading the NASA Supercomputer Centers, or with the code name called TISCs. So with this, within this short few minutes, I covered 3 parts. First is the overview of HPC infrastructure in Thailand. Taking from the report of Vravitya and Prithsa Arun in July 2022 in the 25th International Symposium on Computational Science and Engineering. They performed the surveys of HPC infrastructure in Thailand from the participating organizations, 23 organizations, 13 being university, 4 research institutes, including mine, 3 government departments, 1 state enterprise, and 1 public companies. In short, in summaries from the surveys, Thailand roughly has about 790 HPC nodes with over 64,000 CPU cores with 92 terabyte total memories and 25 petabyte total storage. In terms of GPU, at that time, 149 NVIDIA V100s and 825 NVIDIA A100s. The classification of usage in major application areas. First one is for services, HPC services, and engineering design, basic science, weather forecast, artificial intelligence, as shown on the slide. To further giving example, these are some of the systems listed. A lot of GPU has been more invested recently, and worth mentioned, significant larger than others. For example, in this page from the joint Carnegie Mellon and King Mongkut University of Technology, Lat Krabang University, they have one quite large GPU system dedicated for AI and others. And for on this one, if you see from the this system called Lanta and Tara, is a 2 cluster that hosted by TISC, These have a large amount of CPU and GPU. These are used mainly for services and TMD, time department, or the weather agencies dedicated with the CPU using for the weather forecast. Okay, those are example of applications. In terms of resources distribution among the area, if you see the x-axis, those are dimensions area of usage, and the size of the circle is the amount of resource in that area, and the y-axis is actually the number, how many systems are classified as that. Okay. As I mentioned, and as you see, most of the HPC racks are in the university and government research institute. University systems are connected through this Uninet core network. In the big pictures of the Thailand network connectivities, you can see how the international network peering and domestic peerings. I'm not a network guy, so I'm not be able to explain to you, but I think in the APAN, this is a basic things. You can see the APAN on the upper right with Asia Connect, which connected Trans-Eurasia or TN in the past, and the Internet 2 to the USA. Okay. So the second part I would like to touch upon is carry out from the part that most of the resources are used in HPC services. So the two entities I would like to mention first is the National E-Science Infrastructure Consortiums. The consortium start with the great vision from Her Royal Highness Princess Mahachakri Sirinthorn, who see that collaborating with CERN should raise the level of fundamental science in Thailand, but we are small countries. In that sense, we formed the consortiums founded in 2011 with the 5 founding members institute and expanded to 9 members in 2019. The mission of this consortium is actually sharing the infrastructures usage in Thailand. While the e-science infrastructure covering many aspects, the HPC is one of the major infrastructure of the consortium is being used to support computational science research, as well as facilitating Thai scientists to compute and using the data from LHC data from CERN at the times. Okay. So these are the systems, including in the consortiums. These HPC resources are loosely managed for sharing. Okay, so each site has its own individual management scheme. They use different schedulers and type of application they are keen of that will allow the user to use. So it is pretty much a little bit diversified from the grid computing in the past, but it was not centrally managed. NSCDA are part of this consortium as a secretary and also resources provisions. The picture on the right roughly stated the utilization of million core hours throughout the years of the consortium and the number of projects that was active during those years. Okay. And the last part I would like to talk is actually from Thai itself, NASA Supercomputer Centers. We were formed in 2019, so we were young as a supercomputer center, only 4 years old, and practically almost coming out of nowhere in the international scenarios. It is part of NSTDA as the one of the national science and technology infrastructure missions. Okay. In terms of computational resources. So by its mission, so far, it is the only agencies or entity that providing a tier 1 or national scale supercomputing service. When we start, we have one small system cluster called Tara, which only rating about 200 teraflops only. It has roughly about 4,000 CPU cores and storage of less than a petabyte and on a few cards on the NVIDIA V100. But at the time, even till now, it's the only public usage system for R&D. Over the 4 years usage, 76 million core hours has been provided, over 200 research projects and 700 users. Based on the utilization, classification of the domain usage is provided on the right. And you see the chemistry and computational chemistry consume a lot of computing resources, and followed by the biologies and computational material science. Just three areas together is covering 75% of the utilization that we provided. But in terms of the project objective, is also distributed in these different area of objects. Okay. Tara, over the 4 years, providing service to all sectors. For example, with the in-house of NSTDA to an in-house institution and in-house project on the first row, or on the second row is through a university who come to try and use it on our as a pilot project. And the third row representing a user from government sectors and a large government project. And the last row represents some of our users from the private company and industries. Like BTG is the banking, SCG is the materials and cements. Okay. Our latest system is called Lanta. Lanta is only recently installed. Actually, it's installed in September last year. It's a 346 node heterogeneous system. It is HPE Cray EX models. It has 176 GPU nodes with 704 NVIDIA A100 GPUs, making it the largest GPU cluster in Southeast Asia at the moment, with 160 CPU nodes with 20,000 CPU cores and 10 petabytes of parallel storage. Oh, sorry, 10 high memory nodes for some reserving for a few specific applications. And 10 petabyte of parallel storage and using a 200 qubit interconnect slingshot. The peak performance of the system is 8.1 petaflops, and in the last November in Supercomputing 22 is ranked number 20 in the top 500 and ranked 24th on the Green 500 in the world. However, after that, the installation of application library and user support system, Lanta only started open for service last week. The first group that was in the system is called Pioneer Program, focuses on the field research project, which is a large consumption of the resources in frontier science, in urgent and computing issues and important issue and large scale AI research. And we'll continue to expand the user to cover the market in Thailand from the former user from Tala and also new users. And with the Pioneer programs, we're going to expand, as I mentioned, and we're also exploring the use of these resources across the border. So it could be a shared resource infrastructures for other members in ASEAN as well. We are still exploring that one. In terms of international visibilities, we depend on a lot of our friends to help us a quick start and jump start to our level as it is now. And since we formed, we are representing Thailand in the ASEAN HPC Task Force from 2019, and also a part of EU regional collaboration of EU and ASEAN on HPCs within the framework of the E-Ready programs. These are pictures of one of the meetings that we had in Thailand before COVID era. So after that, since then, we meet regularly about 6 months apart online. One of the achievements that we work in this collaboration is ASEAN EU-ASEAN HPC School. The last one, actually, the 2022 was just recently held as a 5 intensive day school plus 1 additional local event, 5 to 10 December. The school took place in on-site mode with all participants from all 10 ASEAN member states. And the location is used as Kasetsart University and Thailand Science Park. The school was carried out in the framework of the support with the enhanced regional EU-ASEAN dialogue instrument E-Readies. Even though the name is called EU and ASEAN, but actually the school received a larger significant contributions from Japan, particularly from RICANS. Okay, and Fukaku. Okay. All right, that's pretty much giving the overview. If you have any questions, I'm very happy to answer. Thank you.
Thank you, Dr. Piawat, for your presentations. Since you will not be able to join the another session, so obviously we will take your questions as well for you. So just one minute.
Hi, Joe. This is Francis. Congratulations on Thai SC, ranked top 20 in the world supercomputer. What I'd like to ask is, can we open up the training program that you have with EU ASEAN to the other communities, maybe in South Asia? Number one. Number two, how can other people tap on who does not have the HPC resource or capability, tap on the proof of concept for ASEAN HPC? So those are the two questions that I have.
Okay. The first one, two things to answer the first questions. I've typed in the chat now. The materials and actually online recording video of most of the school in December is now available at the website over there, hpcschool.net. So I think it is that is open to publics, and so you can actually, you're interested, you can go into throughout day by day program and also listen and learning from that one. The thing that you will not be experienced is the hands-on experience that you need to be in the school itself. The second one to follow up on that is the next school is now going to be called ASEAN HPC School, will be hosted in Indonesia. Time and dates and details are not yet available, still working on that one, but you can keep a track on the website that I provide on the chat. Okay. And since the school is now called ASEAN HPC School, I think the question or the proposal that you mentioned about the trainings and materials that to be opened up for the others countries in ASEAN or in Southeast Asia or even wider regions is actually in alignment with the way we would like to go. So I think we need to collaborate on that. And beside this forum, we also have many other alliances which has been working together, right? We work toward that one. That's part of how to build our HPC roadmap. The second question is how to, if I get it correctly, you try to get the lesson learned and how the HPC task force and ASEAN chair infrastructure is building up, correct? If I understand the question correctly, we are still in baby stage, right? And let's just me share that when we start ASEAN's HPC task force, the focus was raised by ASEAN that can we have shared research share HPC infrastructure, because not everybody can actually, you have to admit that not everyone can actually build are ready to have a large system in the country, right? There are different maturities. And I think globally sharing of research infrastructure is a trend from demand and supply point of view, okay? In EU regions, in ASEAN, in also all other places as well, because it's a huge investment, short lifetime, and it has to be best used to make a return over investment. I don't know if that answers your question, Francis. Thank you.
Thank you, Dr. Piawut. Yeah, actually, we are also thinking in the same way that the objective of the sessions is that we are looking forward for the collaborative approach. So all the countries doesn't have the same kind of infrastructure, and incomes to the funding as well is a really difficult task. So as a community, I think if we able to share the resources, so that will have the meaningful impacts as well. So thank you for your time, Dr. Piaud. And moving forward, our next speaker is Dr. Lin Gan Chin. Lin Gan from China. Lin Gan is an associate professor in Department of Computer Science and Technology at Tsinghua University. So his research interest includes HPC solutions based on the state-of-the-art systems. He is the recipient of 2016 Asian Gordon Bell Prize. So I would like to welcome Dr. Lin Gan.
Thank
Dr.
you.
Lin?
Thank you.
Please go,
I
please go ahead.
cannot share the screen.
Okay, just a moment. You will get 4
Yeah.
seconds.
It's okay. Can you see my slides?
Yeah.
Okay.
Very good.
Thank you. Thanks for inviting me, and I'm very happy to join this conference and introduce the systems and the applications of the Sunway Taihu Light, one of the China's most powerful systems. I'm Lin Gan from Tsinghua University. Okay, if you look at the first page, the picture here shows our university, the campus of the university. So you are welcome to visit us. And so before introducing the Sunway Taihu Light, I will give a very brief update of China's situation of supercomputing. So we are still building more and more cutting-edge supercomputers that are among the top systems in the top 500. If you look at the latest top 500 list, China has 162 supercomputers, is the #1 in the list. And also we have some different series like the Sunway, Shuguang, and Tianhe, the homegrown supercomputing systems. And also we have some commercial companies that are designing and building their own, brand, their own supercomputers. And also in this talk, I will mainly focus on the Sunway Taihu Light system. And also China is now, more focusing more on the software ecosystem, like the building its own software systems based on its own, processors. So this is a very important step. And also the country has, launched more and more fundings for that, support us to design our own softwares and tools. Okay, now I will mainly focus on the Sunway Taihu Light. So this is a picture shows the city where the system locates, the Wuxi city. So we have a lake, the Taihu Lake. So the city is called the Taihu Star because it's near the lake, and the system is called the Taihu Light because of the lake. This is the symbol of the city. Near the city, we have very beautiful views. We have this is the city that combines, traditional China buildings and also some international buildings, as well as some, very good scenarios. So you are also very welcome to visit our center in Wuxi, and we can see the system, we can communicate, and also we can go to those places for sightseeing. And also this area is the most developed area in China. It's the Yangtze, Delta area. We have Shanghai, Suzhou, Nanjing, and so on. We have lots of developed cities. So we have a very developed industry and lots of universities, research organizations that has a very high demand for supercomputing power. That's why, we build a supercomputing center here in Wuxi. This is the building of the supercomputing center. It's near the lake. It's only less than a kilometer to the lake. And this is an overview of the system. The system is very, well designed. It is it looks like, a 0, 1, 0. The 2 zeros are, the computing part that has 40 cabinets, and the one in the middle is the central network system. So this is some overview of the system. It's the first China homegrown processor, this SW261, 26010. It's based on many core architecture. It has 260 cores in one CPU. The CPU has a performance of 3 teraflops. It is also the first system in the world that's like 6 or 7 years ago. It's the first system in the world that provides over 100 petaflops. In 2016 and 17, it was the top 1 system in top 500 with a peak performance of 125 petaflops and a Limpack performance of 93 petaflops. And also it is a very high efficient, energy efficient, because it's use water to cool the system. It's also cooperated by the state government, the city government, and Tsinghua University where I came from. So this is the general mode of operating mode of China's, top supercomputing centers. The government will, provide the basic fundings, and then it will ask, some universities or organizations that are good at computing system, that are good at supercomputers. The government will ask them to send a team to operate the supercomputing center and also to operate the supercomputers. Okay, this is the architecture of the Sunway CPU. So this is the CPU. Inside one CPU, we have 1, 2, 3, 4. So we have 4 core groups. And inside each core group, we have a master core and 64 slave cores. So the master core is for, making demand, and the slave cores are for computing. So it is on-chip heterogeneous system. We have different kinds of cores, and also it's a many core architecture. So one CPU has 4 core group. Each core group corresponds to 1 MPI process. So one CPU you can launch 4 MPI processes. And so we have one cabinet have 124 CPUs, and the whole system has 40 racks. So that's how we have more than 10 million cores. So we have you can launch 164,000 processes, and inside one process you can have 65 threads. And the system supports DMA. It supports both synchronized and asynchronized DMAs. Very important feature of Sunway, as well as for next generation Sunway systems, is we support thread level communication. That is, each thread core can communicate with each other within a group, so that we can launch very heavy thread level communications. And this is the Sunway software system. We support, so basically for the parallel compiler, we're using OpenCC and MPI and OpenCC, as well as our own programming tool called A-Thread. So this is how we program. We use MPI plus X. X can be OpenCC or A-Thread. OpenCC is is a directive-based programming tool. We are a member of the OpenCC organization, so we support their syntax. And so we are the compiler for Sunway is Sunway ACC for C and C++, and Sunway A4 for Fortran. And this is an example. So if you add a directive here before the loop. The Sunway ACC compiler will, first compile the program into a thread mode into two languages for two parts. The first part is for MP for master core, and the second part is for slave cores. And then it will use a basic compiler for execution. And also this is the example for a thread. A thread for Sunway is like CUDA for NVIDIA GPU. It's more fine-grained, but you need to spend more efforts. Okay, so this is the software support on our supercomputing center. We also have a Xeon system that has commercial softwares like ANSYS and so on. And also we have on our own CPU, we have built some mathematic tools and other tools for FFT and so on. And as I mentioned before, now from now on, we are more focusing on, look at the development of tools and software. So this is the software systems for Sunway Type Light. We can support, lots of softwares on our own CPU. Okay, then I will introduce some important applications that have been scaled onto the system. Now the system has covered, more than 60 large-scale applications that covers 19 application domains. And I will introduce 4 very impressive applications: the Earth system model, some Golden Bell work, CFD work, and also deep learning. So the first one is also very, Earth system application are occupying most of the systems of the Sunway Type Light. So this is a project started like 7 or 8 years ago, and we spent lots of people that port the CSM, the most complicated, one of the most complicated software projects for HPC. We port the whole model onto the Sunway Type Light, and this is an example shows the effect of OpenACC. So for the two part, the dynamic part and the physical part of the model, simply using OpenACC can achieve a very good performance. So this is also what we use. Our users, our domain experts prefer. They can use OpenACC to first, optimize and improve the performance. Then you can look at some particular module that's not satisfying, and then you can use a thread to further improve the performance. Okay, so then I will quickly go through the 3 Golden Bell finals. These are the first 3 Golden Bell finals in the history of China. One is for implicit solver for atmosphere dynamic, and one is for surface wave numeric simulation, and one is for phase field simulations for materials. And those 3 applications have all, being scaled into the whole system with 10 million cores and achieved very impressive resolutions in their areas. And the first one won the Golden Bell Prize. It was also the first Golden Bell Prize for Chinese teams. And then we're also using the system to help find green power like wind power. And this is an example that is collaborated with a company called Divisions. So here we use both Earth system model and also CFD models, computational fluid dynamic, to find the best areas that has the most power of wind. And this is the times to solution using our system. we can greatly improve the performance, and this is the result. We first run the Earth system model to look at the whole a large area and find a particular area that has the most wind power, like in a decades, and then we use the CFD model to look at in this particularly regional area and to find the best place, to launch the machine for wind power. And the last application is deep learning. We're also very interested in doing deep learning. So lots of frameworks like DNN have been scaled onto the Sunway systems based on its specific, based on its fast libraries, and also some important feature like the register communications, the scrap hash memory. We can greatly improve the performance of the framework. This is a comparison of our platform, I think, with CUDA with GPU, and we can, for most cases, we can improve, nearly double the performance of running DNN framework. Okay, so our work is, this is a very famous, deep learning works we already have, and we are, try to, develop both library and framework based on our systems. And these are some very well used, applications, deep learning based applications like remote sensing, cloud change forest in short term, and neural machine translations, and so on. Okay, so that's all my talk today. Thank you.
Thank you, Dr. Lin, for your comprehensive presentations. Maybe you will also not able to join the another sessions. I will take a couple of questions from the floor. So yeah, let me know if you have any other questions, or if not, then at the meantime, so I have the questions regarding the access provisions. How can other countries in the regions can be benefited by the resources that you have? So is there any possibilities of providing access to the other countries, or how we can collaborate together? So that is my questions, Dr. Lin.
Okay, thank you. The system is open to all, and we also have a lots of international users from Japan, from the United States. So if you are interested in using our system, you can go to the official website. You can find a way to apply for an account, and you can use it. And also, now we are the pandemic has gone, and we are open again. So you are also very welcome to visit us in in either Tsinghua University in Beijing, and also in the Supercomputing Center in Wuxi. You are welcome to visit us, and we can talk face to face.
Thank you, Dr. Lin. So your experience will be very valuable for us, as Nepal is at its very beginning phase for hosting these supercomputer services. So your experience will be valuable not only for us, but for the entire regions. Thank you for your valuable time. So I think there are not any other questions.
Thank you.
Okay. Oh yeah,
Thank
there is one question. Just hold on.
I cannot hear the voice. Still, I cannot hear the voice. Can you hear me? I cannot hear the voice.
Yes. Can you
yes.
hear me?
Yes.
Okay. So I think that Sunway typewriter CPU is specially made CPU, right?
Uh,
So many system software was installed in Sunway typewriter system. So I have a question. How many months are delivered software in Sunway typewriters?
I don't have a specific number, but I can tell you the major for major applications like for some the most popular libraries like LAPACK, FFT or something, the mathematical libraries, we can support them. We have software to support them, and for applications like CFD and for module MD and climate, for the mostly used softwares in that areas, we can also support them like LAMPS, GROMAX. We have our own softwares.
Okay, yes, thank you, Dr. Lin again. Moving forward, we have the next presentations from Nepal. So we have Dr. Rajendra Adhikari. He belongs to the Kathmandu Universities. He is actively working for last few years with regards to the awareness campaigns and various training regarding to the supercomputers. So he likes to be called as a volunteer, and he supports the supercomputer centers at Kathmandu Universities, and he's the assistant professor of physics at Kathmandu Universities. So Dr. Rajendra sir, please go ahead.
Thank you very much, Nirajan sir. Am I audible? Namaskar. My name is Rajendra Adhikari. I am a physics faculty here in the Department of Physics, Kathmandu University. So I would like to share my screen and share some thought about supercomputer, how we have operated, managed in a very diverse and adverse, let's say, adverse situation in Nepal. Very unfortunate environment is here. So, but we have working very hard to make it happen. And so far, our journey is very small in comparison to other countries in South Asia and the world. So this was the supercomputer in Kathmandu University before, around 4 years ago. So I would like to thank our technology partners, Andren and Subisu, who are also hosting in this event and sponsoring the event. So our journey, I will discuss about our journey together, since there is no support from university and the government of Nepal. So we are sustaining by our technology partners and well-wishers, and as well as volunteers such as myself. So here, all of you, mostly we are the highly advanced in supercomputing. Let me show these four pictures in the audience who do not have much knowledge in the supercomputing field. So in terms of speed and in terms of correlated works, this figure will explain the idea of supercomputer. So this is how I try to understand Nepalese leaders, policymakers, and university administrators, although they fail to understand this thing. And in Nepal, what we are trying to do is promoting science, technology, and innovation, creating jobs, business, and economic growth, and cost reduction and data integrity of foreign soil computing. And next is human capital. And we have some great belief that while we are working so hard and with great passion is this. And our mission of supercomputer in Nepal is like this. Cutting edge, that is our purpose, research, training and education. Since we are our history is very short in terms of this, so we need a lot of training and education. And I will show you how much we have worked on this. And next is brain game, that we are trying to recall our young talents so they stay here and serve the nation, and developing the data aware society and high throughput computing culture. And this video possibly is the newest exascale supercomputer recently built by US government in Oak Ridge National Laboratory. Maybe you can watch this just a few, I will take more than a minute.
We're talking about improving health. We're talking about improving clean energy. This is a very important milestone for the nation and for the world.
This is a combination of long-term treatment together with HPE and AMD. Today, we are announcing Frontier. It is going to be able to do 2,000 petaflops or 2 exaflops. This machine is going to change the world from medicine to biology to material to deep space to climate change to energy transitions. Oak Ridge National Laboratory working.
Yeah, thank you very much. I will not play that much. So we understand the essence of supercomputer with that video. And the great leader and visionary leaders have taken this as an opportunity to develop the nation, their academic institutions or industry. In Nepal also, we are trying to do the same thing, but we have a lot of hurdle and struggles. And how we build supercomputer is with a partnership with CERN, basically. And we have a long relation with CERN. Since 2013, we are working together. I joined Kathmandu University in 2015. So 2 years ahead, the process has been begun, and I amplify that effort so that CERN will convince to donate us the servers and switches in 2018. So these are the agreements between government of Nepal and Kathmandu University and CERN, so that on these two agreements we were able to get the hardware from CERN, and this is the signatory persons on this agreement from KU and CERN. And this is the handover ceremony of the servers at CERN Geneva. And here my friend Suyog Shrestha is here, and personalities, dignitaries from CERN are on the left sides. So this happened in June 28th, 2018. So this is our team in this supercomputer operating team, and we are all volunteer. We do not take any money from the university or our offices. And one of the my friend Saran Shrestha is in the audience right now in the hall, and others are students and faculties member at Kathmandu University in the figure with a black pant and black shirt. That is myself. And this is our team. So I take pride to always show these great personalities here. And without our technical partners, we were nothing. So I like to thank again with CERN and NREM, Subisu, and NVIDIA. They help us a lot. And with the help of Zoom license and other logistics by NREM, and internet is sponsored by Subisu, and university even didn't provide the supercomputer internet. So I have to talk with Subisu, and they sponsored the internet, and that is how we are working currently. And it's been almost 5 years. Suvishu has provided 100 Mbps dedicated internet to the center. And NVIDIA also awarded 2 GPUs to myself, and I donated those devices to the supercomputer center so that many people can use them without idle time. And in the COVID time, we have done exponential work because of the Zoom and internet, and the GPUs, although only 2, but they were maximum used. And I was, at that time, I used to wake up around 5 a.m. and sleeping around 11 p.m. Just training, user support, conducting workshops, and so many things happened. And this is our achievements on the last 5 years, and I will show you next page. The main thing is that we are able to design, build, and the first supercomputer in Nepal by volunteers and well-wishers. And we trained 200 plus undergraduate students in their final year projects, and 25 plus masters and 5 PhD students are currently working. And 5 schools of Kathmandu University are using the resources. And there are 50 plus publications and 100 citations in high quality journals. And we are operating on zero budget with 24/7, 365 by the volunteers. And we also upgraded our facility. We upgraded 60 terabyte of storage and 2 GPUs and other SSDs also we have upgraded in the system. And organized more than 2 dozens national and international workshops by the center, basically by the volunteers. And we have trained 3,000 plus students, faculties, and researchers worldwide using this facility. And a lot of calculations were completed by now. And we also drafted the directive for the university, but it was not came into action later on. So we have 15 million hours volunteering for setup, operation, maintenance, and user supports by the so many volunteers. And we have a great result in COVID time as well. And this is the performance done by Dulihel Hospital, where Mr. Saran Shrestha belongs to. And they have set up a server in the supercomputer center and performed contact tracing and home isolations system. And they even conducted trainings to government officials so that their performance will grow and they can serve more people. And lessons learned is like this. We are able to design and build and operate supercomputer. It is an innovative, economic, and sustainable approach of doing research and development. And it will, we believe that this will be a digital revolution in Nepal. And our major applications of softwares are like this. Quantum Espresso, which is a density functional package, mostly used by physicists. And there is another package by chemists called NWChem. And OpenFOAM is also heavily used by mechanical, civil, and chemical engineering departments in the Kathmandu University. And GROMAX is mostly used by pharmacy, biotech, and physics. And similarly, parallelly named is also used, which is the similar type of software to molecular dynamics. And there is varieties of MLDL using TensorFlow, PyTorch, and CUDNN on the GPU nodes. And we have built our open drone map processing software, hardware software system also that is used by geometric department to reconstruct the aerial image by drones. And there is environmental department also using for the weather forecasting and modeling, WRF. And this is agriculture. India in this regard is very advanced, that they have built in 2014 this supercomputer called Ashoka. It is particularly dedicated for agricultural computings. And this is the result that we have done in our supercomputer in 2019-20. This is the same Corona time, mostly used by OpenFOAM. And on the right, that is our own hardware. And we have seen a lot of applications in financial market and banking. And although there is very little work has been done, but this is the potential area that School of Management is interested on. And obviously, this is a civil engineering task, geological, seismic hazard and risk analysis. Dhulikhel Hospital and Kathmandu University are collaborating on this part for archiving and processing of digital X-rays, MRI, and CT scans. And we are working to build a AI model for the X-rays and CT scans as well, in the GPU nodes. And we are actively working with National Innovation Center, which is one of the sponsors of this event. And basically modeling the language for the robot called Mina. She is a service robot actually. So I think her model is already developed in the National Innovation Center. And this is another area that we are working with the Department of Music in the School of Arts. And these are the instruments about to extinct because of the very few persons play and know how to play. So we are trying to reconstruct this musical heritage as a pilot case. And this is in Nepali language. Let me pardon for this. This is about statistical analysis and new emerging energy sources. And overall, this is a strong pillar of economic development of the country. And why we should spend? We are trying to pursue the government and policymakers that we have to build a national supercomputer center. Although that is and there is a directive in 2016, I guess, by the Ministry of Science and Technology. And there is so many provisions that although this is in Nepali language because it is written in Nepali, this is a ministry document itself agrees that they have to spend. The highlighted text is the major point I have highlighted, why to invest on supercomputing. So there are so many points here that nations should invest in supercomputing hardware that will save cost, energy, and resources, everything, and expedite the research and innovation at the minimum cost. And we have proven feasibility at Kathmandu University that we are able to build, operate, and manage supercomputer ourselves. And this is an example of Indian food serving called Langur in Punjab, Indian state of Punjab. And this is called a National Kitchen Center because this is a very economic meal serving. And if we establish a National Supercomputer Center, our computing cost will be hugely reduced. So therefore, we have to build such facility. And I have also provisioned a financial modality for this. And government part is initial hardware and infrastructure and other costs. And users like universities and private sector will operate and maintain the supercomputer. So this is particularly very suitable in Nepalese context because we have skilled manpower in Nepal for the supercomputer. Only thing is that we have no money. Only government has money or university has a little bit money. So if they initially invest on the hardware and other infrastructure such as data center type power and cooling and networkings, then operation and maintenance can be done by the users voluntarily. That is also. And I have also set 5-year goal for the Nepal that in academic particularly, we have targeted 100 PhD students and more than 1,000 publications in high quality peer review journals. And government may want his own interest that I cannot guess at the stage, but they can, I can assist them. And another is training, because we have very few people trained in computing, and it will also create jobs and business. So, and similarly, private sector can also achieve their lot of computing right in Nepal without investing into cloud resources. So that will be a huge economic and financially much beneficial to them as well. So I have also designed a peta-scale supercomputer with a diverse. These are mainly the factors that affects in context of Nepal. I have seen the different compute fleet for different computing domains and very good hardwares and softwares. And we have always emphasis on the open source softwares because of their user support and less financial cost of ownership. And other part is reliable and bigger storage are another factors. And here is the block diagrams. Some nodes are faster clocks and some nodes are more clocks, and some nodes are high memory and some are GPUs, service, storage, and here. So these are the design philosophy that we are going to implement later on. And final thought is this: the era of supercomputer started in Nepal, and supercomputer opens the door of immense possibilities, but we Nepalese are limited by our own imagination. And what I am trying to say is, let us do something very economic, productive, and powerful by establishing a national supercomputer center. And finally, I always like to show these two figures. One is silkworm, another is cow. So these two, their input is very less. One both basically eats leaves, grass. So what they produce is very important, very economical, high value content. One gives milk, a highly nutrient food, and another is silk, which is a very important cloth, fabric. So finally, I would like to thank you for your kind attention, and a special thanks to our technology partners, Yanren and Subisu, who provides internet service in Nepal and which has been graciously provided internet service for the supercomputer center. Thank you very much.
Thank you, Rajendra sir, for your presentations. And yeah, I want to reiterate that he's one of the few people who has been continuously advocating for the supercomputer services and resources in Nepal. We Andren are also happy to tie up with Uniforce. So it's a really amazing things. So if there is any questions, I will take from the floor. Yeah, Francis.
Hi, Rajan. It's amazing what you have been able to do with the limited resources you have. I'm just wondering, what's your list of things that you would like to see happen in the immediate?
Actually, from the day zero, our model was data center type infrastructure, which we missed initially while we were about to get the hardwares from the sun. So that was still lacking us to go ahead. That is the first thing. Another is our hardware, which are currently with us, is a little bit time to upgrade. In fact, although I can still see that we can use 10 more year for training and tier 2 or tier 3 resources. So, and would like to upgrade few of the machines that are very latest in the industry.
Running a supercomputer is very, very expensive.
Right. That's
Yeah,
right.
it's not only a one-time cost, but the maintenance cost of it. So there's another avenue, which is like open science foundation, data foundations, which have resources that are open for people to use. So although they are distributed resources, and may not be up to scale, but they are resources, and actually some of my students use that as training. So things are changing very quickly. Yeah.
Yes, that's right. Generally, what we are trying to do is let us play the students, because we are from university, and let students learn how to do jobs in supercomputer, how to use supercomputer. If we have our own on-premises device, they can play. And there is two groups of students here. One groups are like how to use supercomputer, and another groups which are particularly from computer physics or mathematics department. I'm trying to train them how to build and operate manage supercomputer as well. So if we have these machines here or data centers, then both kind of manpower will be developed in the country. So I'm working on that direction basically, and that was the basically, let's say, a goodwill of Sun to us, that let Nepalese build, design, and work so that they will be more familiar with supercomputing. So I'm mostly working on their, or our requirement is also that. This is how we are working with our passion and interest. As much as time permits, we are working.
Thank you.
Yeah, you're welcome, sir.
Okay, another questions?
Thank you, Professor Rajan. It's a great contribution. You are doing a lot of concerns of supercomputing, studies supercomputing. But I have only one, since Francis has also said, like, it's really very, very expensive for Nepal to establish our one supercomputer that what we have in foreign train in the globe. So have you ever explored that whether the having your one infrastructure is good, or getting existing server supercomputers has been mentioned that we have?
Yeah.
So
yeah.
have you ever explored why don't we go for the exploring that existing supercomputing things? What is the benefit of having our one supercomputer?
Yeah, thank you very much, sir, for this question. Actually, like I previously said, from the university domain, our target is to learn also. So only for the using supercomputer is okay, we can use anywhere where we can get from our collaborators or any well research. They provide us computing resource, that is very fine. Whereas a university setting, we have to learn ourselves and teach also. On that case, that was difficult mostly because so that is one major purpose, and another is obviously if we have since we do a lot of computing, then those resources maybe may have some limitations in case, then it will always better. And generally, let me tell you one thing, sir. Supercomputer is, I would say, not expensive in terms of its production. So if it produces more thing over the time, like ROI is in a commercial language, then I would say it has very less ROI, or cost of ownership is very little in terms of its production. So it's like a working horse. That's why I showed you somewhere a horse and cow or silkworm. Their input is just electricity. And in Nepal, I have developed a good talent pool. They are ready to work voluntarily to operate and manage. So our ownership cost is substantially low in comparison to other countries who might have a dedicated team of dozens or 2 dozens people for the operation and maintenance as well as user support. So therefore, our cost of ownership is very little. So I would say supercomputer is not expensive, sir, in that case.
Thank you, Rajendra, sir.
Thank you very much, sir.
Okay, yeah, we have another questions as well. So yeah, we have just 10 minutes for chatting.
Thank you. Thank you very much, Raj sir, for great initiative and work done at Supercomputer Center. Basically, I'm from Midwest University and I'm teaching faculty at the computer department, so the Department of Computer. And actually, more than the query, I would like to know about the access of that supercomputer and how can we teach our students about the work done at supercomputer. Please let me know. I have also talked with Saran sir. We are closely talking. Yeah. That would be great. Thank you.
Okay, I think we have met in Surkhet possibly already, if not, if I am not mistaken. I actually promoting supercomputer in Nepal. I have gone Surkhet 2 times to train physics students there already. So actually now that batch, which may have already passed out now, or still in the university. So this is how basically that is also assessing the supercomputer. So our mission is always twofold. One is training the students how to do work on supercomputer. Another level is the training researchers, real researchers or faculty members of the universities who can have some production type of work. One is learning work, another is production work. So I think we have already established that with Midwestern University. Once I got a call and I will immediately go there and train. So this has been done. Just recently I went Biratnagar in the eastern part of Nepal and I conducted 3 days workshop on density functional calculations and quantum chemistry calculations. So wherever I get call and my time permits, I will jump to teach there.
Rajendra, this is Taurik from BDRAN. I have a small question. I don't know whether I missed that slide. What is the capacity of your HPC in terms of flops or number of boards?
Yeah, actually, we have 2 kind of machines, sir. One is conventional CPU that servers that we get from Sun. We actually calculated, could not measure because we never gone on full scale deployment of our system. So 15 point around 16 teraflop is the CPU benchmark of the highest theoretical, but GPUs are much more advanced. We have 2 GPUs with a Quadro RTX 6000 and another Titan V. So which will push out most of the machine learning or deep learning calculations and other conventional calculations as well as density function also we perform in the GPU. So we never going to measure, but we have calculated around 100, I would say, teraflops in that, or slightly more in double precision.
Thank you, Rajendra sir, for your time and your valuable inputs. Andren will be there to support whatever way possible, and will approach to other communities in the regions as well. So Andren yourself is trying to link the resources that we have at the Kathmandu universities and UN universities to our other members across the country. So that's a very good part from you. So thank you so much again,